Alright, here's the data for the picket fence, and I'm going to show you how we find the acceleration due to gravity. So this is the data. You will see that they are data very close together. So first thing we are going to do is to maximize the graph. So go to the very first menu all the way in the corner over there, click on it, and it'll go like this. So this is for speed versus time, so it looks like almost a straight line. That's what you expect. So what we are going to do is we are going to highlight the data. So use this one to highlight the data. So if you click on that, so let me see. Oh, sorry, you have to come back and click on the data points, make sure the data points are highlighted, and then go over here, click on it. This box come around, and you can try to highlight as many data points as you like. So drag it out. Okay, and then we are going to do a linear fit here. So click on this one here. And then you're going to choose linear fit, and then if you click it anyway outside, it's going to put the fit over here, and you will see the fit. And then again we are looking for the slope, because that is going to be the acceleration, which is the acceleration due to gravity, and in this case I'm getting 9.62 here. You see that for the slope. All right, so we are looking for the number after m. It's like y equals mt plus b. So m is the slope, which is 9.62. Now the unit for that, of course, going to be meters per second squared, because we are dividing meter per second by second. Now how do we find the second part, right? This is from v versus t graph. Now we also need to do the quadratic fit. All right, so for that, what you do is come over here, click the speed, and you go to position, and you're going to go to this one graph. Now you see the linear fit is not going to work, because the position versus time is going to be a quadratic function. All right, so what you're going to do is come over here. Well, we should get rid of this one first. So let me get rid of the fit part first, okay? And then I'm going to highlight the data. So once again, I'll highlight my whole data, drag it down all the way here, and then I go over here, click the fitting menu, drag it down, and I'll try to fit the quadratic here. The quadratic should fit anyway if you do that. So when I chose the quadratic, you see that we got a pretty good fit. So click anyway outside the box, and you see the curve over here, and then you can drag it around and you see the fit anyway. So the tricky part is what do we do here, right? So we look at the fit. I'm getting 4.8 t squared, okay, plus and then there is anyway, so the question is, how do we find the t squared term is the one we are looking for, which is 4.8. all right, but remember that the t squared term is actually 1/2 a, okay, so 1/2 a is going to be 4.8. so then you can find a as basically 4.8 times 2, all right, or you can divide 4.8 by 1/2, and that should give you the acceleration, which is 9.6. so that's the way you get the acceleration, using the quadratic fit. All right, because the quadratic equation you have for position, x is v naught t plus 1/2 at squared, and v naught is 0 in this case, because we dropped it with 0 velocity. So what we are looking at, just the 1/2 at squared. Okay, so 1/2 at squared is basically equal to 4.8. So that's the way you find the acceleration. All right, so you need to do this a few more times, and also you need to do this with the 50-gram mass attached to the picket fence, and you can do that. There's a tiny hole here, you see that, okay, and then you can attach a string over there and attach a piece of 50-gram mass and then drop it. So hopefully you will see what happens with that. So the question is whether increasing the mass will affect the acceleration due to gravity is a question, I guess. All right, that's all I have on this one.